Hi students, welcome to HSC Earth and Environmental Science. This is Module 6 on hazards, and we're going to be looking at video number 20, the third in our little mini-series on some of the technologies that we apply to different types of hazards, particularly around their prediction and preferentially some sort of early warning systems. So this time we're going to focus on East Coast lows. Just as for the others, but with a slightly smaller list this time, we want to look at the effectiveness of technologies in predicting natural disasters, particularly these East Coast lows. And we're going to focus a little bit on temperature and pressure systems in this video. Now, the extreme East Coast lows actually produce cyclonic conditions. So this is a little bit about sort of trying to get a bit of an idea about how cyclones can form and where they might actually move onto the land, where of course they can have quite devastating impacts, and how effective we can be at trying to predict not just where these cyclones are, but their path of motion. So in this final little video in this series, we're going to be looking at cyclones in particular and East Coast lows in general. And for us here in Australia, the Australian Bureau of Meteorology is the one that has the largest amount of information that is relatively up to date. And that's one of the things that's really important when we look at weather systems. We know that the weather changes daily. And in fact, often within the course of a day, there can be quite different weather conditions, which means that if we're going to be trying to monitor weather conditions, we need to make sure that we're updating our information as we go along. The prediction of future weather events is very much around data and measurement, and a lot of weather recording stations are located in all sorts of different places, both ground-based and satellite-based, that are all taking measurements in real time and delivering those usually through computer means to be tracked, stored and analysed to give us a good picture of what's actually going on, how winds are moving, how pressure systems are moving, how they're forming, ones that are maybe moving away from the sphere of influence in terms of our local regions, and so on. So there's a lot of computer modelling software, large amounts of computer power, and lots of data that go into weather forecasting, and it really is quite a complex science. That said, it's also, I guess, a science where we do have a lot of grey area, where we are not as good at predicting and modelling as we'd like to be, even with all of this information and all of this computer power at our fingertips. And that's because there is a level of unpredictability in the way that the atmosphere moves things around, heats and cools, shifts some of these convection cells. There's the Coriolis effect that's added to all of this, and then there's differential things that happen from time to time in terms of differences between the heat on land and heat in the oceans, whether the currents are bringing cooler water towards us or warmer water towards us. There's a whole lot of different effects, and as we know in science, the more variables that you have that you can't control, the more difficult it is to be able to link causes and effects, or at least link an independent variable with a dependent variable. So that's the nature of weather, unfortunately. Lots of different variables that we're trying to put together. However, if we do find that certain indicators from the data that we've looked at are suggesting a fairly serious weather event, then there are weather alerts that are going to be issued to the relevant regions. These might be statewide, these might be local communities, these might be regions along the coast, particularly if there's aggressive surf, high swells, those sorts of things. Storm advice can be updated at half-hourly intervals. So when we know that there's a severe storm that's building, we can track its path, we can see where it's coming. And I'm sure you've looked at those rain radars from things like the Bureau of Meteorology to see how clouds and rainfall have moved over certain periods of time, and they seem to get updated on a regular basis. So what we want to do, if we're going to be any good at trying to get some idea about these East Coast lows, when they're going to hit, how bad they're going to be, we need to combine ground-based stations, airborne monitoring systems, weather satellites, that are in geosynchronous orbit. So geosynchronous basically means they're going to stay in the same position. We've worked out their speed and their distance from the Earth to keep them in the same sort of position relative to the ground underneath, so that we can get a bit of an idea about how these conditions are changing in real time. So what we have to look at in this particular video, especially in relation to East Coast lows, are two things: pressure and temperature. So let's look first at pressure, because pressure is the thing that you most often notice about these synoptic charts. So when we look at these synoptic charts, we're looking at numbers, and these numbers are a measure of the atmospheric pressure. And the lines are called isobars because they join different points of the same pressure. As a result of that, we get either the isobars increasing, and if they are increasing, then we've got a high pressure system. And if we have a high pressure system, then that means that we can kind of identify some anti-clockwise winds that might be circulating around that particular system. If the numbers are decreasing, so when we have numbers getting smaller as they go towards the center, then we have a low. And you can see here, there's a low pressure system. It's quite a significant low pressure system. This is being recorded on Sunday, the 3rd of April, 2022. So this is a current synoptic chart. And so it's a good one for us to use to make predictions, today anyway, about what we think might happen. And so we've got another one of these East Coast lows. Now it's much lower than we would usually expect. So we expect a lot of these are going to kind of move down from the north. But the problem ones are the ones where we form these lows over warmer water in the ocean, and then they kind of get stuck. They run into a high pressure ridge that blocks their passage. What that means often is that we see these isobars getting closer and closer together, which you can kind of see happening in this little low pressure system here. And that's going to be an indication of increased wind speed. Now, also, if it sits there, what it's going to do is likely dump a whole lot of rain. So there's a fair chance that this low pressure system, which is coming back onto the coast down around Victoria, southern New South Wales, may well bring more rain coming through onto the coasts some point later in the week. Now, of course, if we're going to try and get a sense of what's going on, we need to add our wind directions. So clockwise, I remember in the southern hemisphere, which is where we are, it's clockwise around a low. So we know that the winds are going to move in a clockwise pattern around the low. So that's also going to give us an idea about what sort of winds we can expect happening on the coastal side as this low pressure system continues to build and to move. Two important things to remember when you're trying to interpret pressure systems from these sort of synoptic charts is that convection currents tell us that warm air rises. So warm air is rising away from a low. So the low pressure system actually has air moving off the surface, and that's why it's a low pressure system. And warm and cooler air falls. So cooler air is going to drop onto the center of a high pressure system. So we've got this high pressure system which has got air coming down towards the surface, which creates that high. Now this is established through convection cells. So we've got areas where we've got a cycle of warm rising and cool falling. And so we close this and we get these convection cells. Now this would be reasonable, and of course you've got to look at relative things too. So when we look at the ocean, we know that the ocean temperature is more constant. The changes are maybe seasonal, whereas when we look at the land, the temperatures change daily. So it may well be that the land is warmer in parts of the day and then it cools off later in later parts of the day, and so between that it's going to shift from radiating heat up and away from the land surface to actually bringing the cooler air back down to the surface. You add to this the Coriolis effect, and the Coriolis effect is based on the fact that the Earth isn't stationary. It spins on its axis, so because it's spinning, that means that whatever winds are generating are also going to be influenced by the spin of the Earth. And so that's one of the things that makes these quite difficult things to interpret, because you've got a couple of things happening at the same time that you're trying to understand. The one thing that's very important, though, is these low pressure systems, when they're forming off the east coast, if there's a ridge of high pressure that's coming through that's blocking that low pressure system from moving, it's going to keep it on the coast for some time, and that's where we get our big winds and our big rain. In the north, we tend to get even worse up here, and often they'll be cyclonic. And again, what you need to do if you're going to look at those sorts of things is you want to look at a low pressure system where you've got a lot of those isobars very close together. We've got higher wind speed, which is characteristic of cyclones, and often we also have a large amount of rain. So the other thing that we need to look at briefly is temperature. And temperature is very, very important to our formation of east coast lows, because we need a large temperature gradient. So we need a significant difference between where the cooler air is, where the low is, with the warmer air, and where our land is. So when we're looking at our highs and our lows, we're trying to look at where that cooler air over the land is, coming across, meeting the warmer air that's being created over warmer oceans. And as they move together, and we see that difference in temperature, if it's high enough, then it can create a little barrier, a little blocker from moving from the low, moving further across onto the land. And as a result of that, it sits on the coast, and that's what creates all these great rain events that we've experienced in along the New South Wales or east coast of Australia pretty much for about the last month or so. As I said, weather station data, which comes from both ground-based and satellite-based monitoring systems, keep regular checks on or updates on the air pressure or the atmospheric pressure, and also the temperature. And this can include both air temperature and water temperature, because there's a number of these that are also located in and around the oceans. We can also look at wind speed and direction, and this also gives us a little bit of information about what might be happening in the future to our pressure systems, our lows and our highs. And this helps us maintain currency. This means that each time we go and analyze these synoptic charts, we're trying to do so with the latest information that we have available. And because we've talked about the fact that systems can change in very short periods of time, and particularly if we want to issue warnings around potential weather events, then we need to make sure that we're using the most current data we possibly can. So one of the things that I encourage you to do is to start to have a look at some of these weather maps. Maybe you can turn the weather report on when the news is on and turn down the sound, and see if you can just have a look at these maps and start to get a little bit of an idea for your area of what sort of weather pattern you might reasonably expect. Where are the winds coming from? Think about in the southern hemisphere, it's clockwise around the lows, anti-clockwise around the highs, and obviously it's the reverse for the northern hemisphere based on the Earth's rotation. We can look at putting some of those in. We can look at how close the isobars are together and think about some of the changes that might be a result of that. We can look at the interaction between highs and lows and the fact that that may create some instability in the weather patterns. Certainly, if we're seeing air that's being brought from the ocean, we can often associate that with rain, which may well drop on the coast rather than continue to move inland and dropping that on the inland centres. So weather forecasting is not I guess, something you particularly need to do a lot of in this course, but it's probably useful for you at least to be able to start recognizing some of these little patterns and how we can go from a synoptic chart like this to a forecast of what might be happening tomorrow. Thanks for watching.